Hi, welcome to the Olympiad geometry. Let's continue our study on Excenter. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Here is a problem. Circle IA is a x-circle of triangle ABC in angle BAC. Okay, I just mark the circle IA, right? The center of the IA here. D is a tangent point of circle IA to BC. So I just make a projection here. Okay, D is a tangent point of the circle IA to BC. E is any point inside of segment BC. The excenter of triangle ABE and triangle ACE are I1, I2. Prove that I1D is perpendicular to I2D. Okay, we want to prove this is 90 degrees. So in Chinese version, I actually use a way that of reverse thinking. So in English version, I want to make it more smooth. I mean, it looks like I already know how to solve it, so I can write the solution smoothly. But the reverse thinking is a way that I think of how to solve the problem, but it's kind of difficult to explain. So let me just smoothly write it down first of the solution, and then I can reversely talk about how I start think of this problem. Let's try this way. Okay. So the first thing that we can think about of this problem is that we already know that circle I1, circle IA, and circle I2 are all tangent to segment BC, right? And D is a point that IAD is perpendicular to BC. So we know that if we find the other two tangent points of circle I1 and circle I2, it might be helpful, right? So I directly draw the projection from I1 to BC and the projection from I2 to BC. Let's call the foot as F and G, right? So the problem is asking us to prove that I1D is perpendicular to I2D. One thing we can think of is that E is any point on BC, right? And I1E. So let's call this point as X, this point as Y, and this point as Z, okay? So I1E is the angle bisector of angle BEX, right? Because I1 is excenter of the triangle ABE. So I1E is the angle bisector of angle BEX. And I2E is the angle bisector of CEX, right? Because angle BEX plus angle CEX equals to 180 degrees. That means half of it. Half of it equals to 90 degrees. That means angle I1E I2 equals to 90 degrees, which means I1E is perpendicular to I2E, right? Which means if angle I1D, I2 is 90 degrees, we know that I1ED, I2 are cyclic, right? So if I1D is perpendicular to I2D, then I1ED, I2 are cyclic, which means we want to find a way to prove that I1ED, I2 are cyclic. So here I just draw. So I1, I2. And directly prove that I1, ED, I2 are cyclic is kind of difficult. The method I choose here is to do some calculation to find the relationship between relationship of B, F, E, D, G, C, right? The first thing that we notice here is that because we already know that angle I1, E, I2 equals to 90 degrees, so we know that angle FEI1 plus angle GEI2 equals to 90 degrees, right? Which means this is 90 degrees, this is 90 degrees. So which give us that triangle EFI1 is similar to triangle I2GE, right? So we know that FI1 to FE equals to GE to GI2. That's the start of the thinking that I want to calculate for FE and GE, right? Because FI1 is R1, GI2 is R2. They all can be represented by the, if we already know the length of the BE, they all can represent by the A, B, C, B, right? But what about the FE and the GE? We don't know. So let's just do a short review of what we learned before in the Excenter, right? Excenter property. So consider that we have a triangle and Excenter here. So this is A, B, C. So angle bisector. So angle bisector. So because this line, and this line are the angle bisector of this angle, and this angle, right? So we know that the distance from the excenter to three edges are the same, right? Which means we can easily calculate for this distance. So let's call it DEF here, right? If we set this length as x, that means this length is x, and this part is y, so this part is y. So we have x plus y equals to a, right? X plus y equals to a. And also we know that AB, or let's say AE, is C plus X, and AF is B plus Y, and they are equal, right? Because the triangle AEIA is congruent to triangle AFIA. So from here, we know that y equals to a minus x, right? Y equals to a minus x, so c plus x equals to b plus a minus x, which means x equals to half of a plus b minus c, right? Which is p minus c, right? That's x. That's this distance. And y equals to p minus b, right? So we can consider it as x is distance from B to the projection point D, right? So that's a BD, that's x. So it's P minus the edge on that includes the vertex B. So that is edge AB, right? The length of AB is C. So it equals to P minus C, that is x. So for here, if we assume triangle ABE, the parameter of the triangle ABE is P1, and the parameter of triangle AEC is P2, and the parameter of the triangle ABC is P, right? Then we can write down all of these segments like this. BF equals to P1 minus, look at here, P1 minus AB, right? AB is C. That is BF. And FE is P1 minus AE, right? And EG, right? EG equals to P2 minus AE. GC equals to P2 minus B. And for the triangle ABC, we have BD equals to P minus C, right? And the DC equals to P minus B. So if we look at here, FE and GE, right? We know the length of the GE, this one. And we know the length of FE, this one. What about DG? DG equals to DC minus GC, right? Equals to DC is P minus B, and GC is P2 minus B. So it equals to P minus P2, right? What is P minus P2? P is half of AB plus BC plus CC, so it equals to half of AB plus BC plus AC minus P2 is half of AE plus EC plus AC, right? So it equals to half of AB plus BC plus C. AC cancel, right? So minus AE minus EC. And AB plus BC minus EC. BC minus EC, that is BE. So it equals to half of AB plus BE minus AE, which equals to half of AB plus BE plus AE minus AE, which is P1 minus AE, right? And P1 minus AE, we already know it's FE. So we got FE equals to DG. FE equals to DG, which means FD equals to GE, right? FE equals to DG, so we get FD equals to EG. They both add ED. Now we can say that FI1 to FE equals to GE to GI2, which means Fi1 to, because Fe equals to dg, so I replace it to dg. Because Ge equals to Fd, I replace Ge to Fd to Gi2, right? Let's see here. Fi1 to dg equals to Fd to Gi2. And this is 90 degrees, this is 90 degrees. That means triangle FDI1 is similar to triangle GI2D, right? And based on this, we know that angle FDI1 plus angle GDI2 equals to 90 degrees, which means I1D is perpendicular to I2D. Okay, so for this problem, all the things down to here, I did the forward thinking, like we already know the problem set, what we can get here, right? And then I was stuck. I get nothing from there, right? I know that I want to prove these 4 points are cyclic, but what else? Then the thing happened is that I noticed that if I1, E, D, I2 are cyclic, then we can get the conclusion that Fi1D, the triangle Fi1D is similar to triangle GI2D, right? These two triangles are similar. And then I start think about, because the angle are difficult to use for the proof of the similarity of the two triangles here, then we have to find ways to use the length, right? And the length here, we already know that this is R1, this is R2. The only thing that we don't know is about Fe and Ge, right? Then it's clear that we want to prove that triangle Fi1D is similar to triangle Gi2D. And we can easily find the length of Fe, but we don't know the length of Fd. So we want to calculate for Fd or dg. And once we calculate for dg, we notice that it equals to Fe. Then we know that Fd equals to Eg. Then everything becomes clear. Okay, so I think this problem is mediate to hard level problem. It's just because sometimes it's difficult to recognize that we want to use a edge to do the calculation, and as you can see here, it's a lot, right? So we need to be very familiar with properties of the Excenter, and we can list all the lengths of the edges, and then we can figure it out that dg is actually equals to Fe. Okay. I hope you like this problem. I hope you like this video. See you in next one. Thank you.